The sun shone brightly over the bustling city, its rays glinting off the glass skyscrapers and sparkling ocean. But this idyllic scene hit a ticking time bomb. As the temperatures soared, the aging power grid creaked under the strain. A victim of extreme weather events, 2021 alone, the U.S. was hit with 20 separate billion-dollar disasters, causing widespread power outages and highlighting the urgent need for action. As temperatures rise and weather patterns shift, our power grids are being pushed to their limits. And if we don't take steps to protect them, the consequences could be catastrophic. And sustainable power systems that can withstand the challenges of a changing climate? Also, what exactly are smart grids, and how can they help us build more resilient power systems? Upgrading equipment and strengthening connections can enhance the resilience of our power grids against extreme weather events. For example, investing in underground connections can help prevent damage from storms or falling trees, while strengthening equipment can reduce the risk of outages due to high winds or extreme temperatures. The storm had caused widespread destruction and left the island without power for months. In response, Puerto Rico has since invested heavily in microgrids and renewable energy, particularly solar. The EU is committed to reducing its greenhouse gas emissions by at least 55% by 2030. By investing in innovative solutions such as smart grids and microgrids, we can create more sustainable, secure, and reliable energy systems that can withstand the challenges of a changing climate. The challenges are significant, but so are the opportunities. By investing in our power infrastructure, we can create jobs, stimulate economic growth, and improve the quality of life for millions of people. The question is, will we take the necessary steps today to build a more sustainable and resilient energy future for generations to come? Will you join me in calling on policymakers and businesses to invest in our power infrastructure? Together, we can build a brighter, more sustainable future for all. And has set a goal of generating 55% of its energy from renewable sources by 2030. To achieve these goals, the EU is investing in smart grid technologies to improve the efficiency and reliability of its power systems. For example, the EU-funded project, titled Smart Network Services for an Integrated European Energy Market, aims to enhance the integration of renewable energy sources and improve the efficiency of power grids across Europe. The project is developing a platform that enables energy communities and prosumers, which are consumers who also produce their own energy, to exchange electricity locally. This can help reduce the need for long-distance transmission and improve the resilience of local grids. In fact, the island has seen a 400% increase in distributed solar capacity since 2017. This shift towards distributed energy resources has enhanced Puerto Rico's energy resilience, allowing communities to generate their own power and reducing the strain on the centralized grid. To fully harness the potential of renewable energy and build truly resilient power systems, we need to embrace a more distributed approach to energy production and consumption. The state has seen record-breaking wildfires in recent years, which have caused widespread power outages and significant damage to property and infrastructure. To address this issue, California has been investing in smart grid technologies to better manage the risk of wildfires. The California Public Utilities Commission has launched a major initiative to improve the state's electric grid and wildfire resilience. Part of this effort involves upgrading equipment and strengthening connections to reduce the risk of outages due to high winds or extreme temperatures. Additionally, California has been investing in distributed energy resources, such as rooftop solar panels and battery storage, to reduce the strain on the grid and provide customers with more reliable service. This means moving away from the traditional centralized grid and towards a more decentralized system that is more robust and less vulnerable to disruptions. One promising solution in this regard is the use of microgrids, which are small-scale power systems that can operate independently or connect to the main grid when necessary. Microgrids can be powered by a variety of renewable energy sources such as solar, wind, or battery storage, and can provide energy to a single building or an entire community. By diversifying our energy sources and distribution networks, we can reduce the risk of widespread blackouts and ensure that critical services such as hospitals or emergency services continue to operate during extreme weather events. Smart grids are essentially networks of electricity connections and devices that are interconnected and capable of communicating with each other in real time. For example, the European Union has committed to large-scale investments in grid modernization and renewable energy to strengthen energy security in the face of climate change. Similarly, the California Public Utilities Commission has launched a major initiative to improve the state's electric grid and wildfire resilience. These efforts are crucial for building more resilient power systems that can withstand the challenges of a changing climate. However, we can all do our part to support this transition. By supporting policies that promote renewable energy and grid resilience, we can help create a more sustainable and secure energy future for ourselves and future generations. We can also make changes in our own homes and businesses, such as investing in energy efficiency measures or supporting companies that prioritize sustainability and responsible sourcing. Every small step we take can contribute to a more resilient and sustainable energy future. This allows for a more dynamic and responsive power system that can adapt to changing conditions and integrate renewable energy sources more effectively. One of the key benefits of smart grids is their ability to monitor and control power flows in real time. By using sensors and advanced algorithms, smart grids can detect outages or other disruptions and quickly reroute power to maintain continuity of service. This can minimize the impact of extreme weather events and reduce the likelihood of widespread blackouts. Additionally, smart grids enable consumers to manage their energy usage more efficiently, which can reduce demands on the grid and help balance supply and demand. This is particularly important as we move towards more renewable energy sources, which are often intermittent. Overall, smart grids represent a significant step forward in building more resilient, efficient, and sustainable power systems that can withstand the challenges of a changing climate. Just days before, a powerful storm had swept through the city, leaving behind a trail of destruction and blackouts that had lasted for days. Another crucial component of building resilient power systems is reducing our reliance on fossil fuels and embracing renewable energy sources. As we transition to a cleaner, more sustainable energy future, we must also ensure that our power grids are equipped to handle the challenges of a changing climate. Fortunately, there are a number of promising solutions on the horizon. One of the most promising is the increased use of distributed energy resources, such as rooftop solar panels and small-scale wind turbines. These resources allow consumers to generate their own power, reducing the strain on the grid and increasing overall reliability. Another exciting development is the growth of energy storage technologies such as batteries and pumped hydro. These technologies allow for the storage of excess energy. It can then be used to supplement the grid during periods of high demand or extreme weather events. Moreover, advancements in grid-scale energy storage are crucial for enabling higher levels of renewable energy integration. By storing excess renewable energy, we can ensure that power is available when the sun is unshining or the wind is unblowing, enhancing the reliability and sustainability of our power systems. And as climate change continues to cast its long shadow, the threat of such disasters looms ever larger. Welcome to Gravitas Plus. I'm the host. Extreme weather events like hurricanes, wildfires, and heat waves are becoming more common and more intense due to climate change. The recent Texas blackout serves as a stark reminder of the fragility of our power systems. When the state was hit with a winter storm, the grid failed, leaving millions without power and hundreds dead. Our current power grids were designed to withstand the average, not the extremes. Traditional grids are centralized systems that rely on large power plants to provide electricity to consumers over long distances. While this approach has worked well in the past, it has left us vulnerable to the impacts of climate change. Storms become more intense, heat waves more prolonged, and cold snaps more frequent. Our grids are struggling to keep up. This raises concerns about our energy security, economic stability, and public safety. Extreme weather events can cause widespread blackouts, disrupt critical services, and lead to economic losses. For example, the 2021 Texas winter storm caused an estimated $210 billion in damages, including $136 billion in lost economic output. Such events not only highlight the vulnerability of our power grids, but also the far-reaching consequences of climate change. And as climate change continues to wreak havoc, similar situations are likely to become more common. But it doesn't have to be this way. With innovative solutions and forward-thinking policies, we can build power grids that are not only more resilient, but also more sustainable and efficient. From smart grids to decentralized microgrids, the tools are at our disposal. What we need is the will to use them. So let's take a closer look at the challenges and opportunities ahead, but there is hope on the horizon. By investing in smart grids, we can build more resilient, efficient. But smart grids are just one piece of the puzzle. But it's not just about adopting new technologies. It's also about making changes to our existing infrastructure. The good news is that many governments and organizations are already taking steps to invest in and promote these innovative solutions. Let's look at some case studies now. After the devastating Hurricane Maria in 2017, Puerto Rico found itself in a precarious situation. Another great example is California, which has been grappling with the dual challenges of wildfires and extreme heat waves. The European Union is also stepping up to the challenge by investing in large-scale projects to modernize its power grids and integrate more renewable energy sources. These case studies demonstrate that building more resilient power systems is not only possible, but also economically viable.
So now, a bit about me. My name is Mike L., and I am an experienced electrical engineer who has worn many hats, holding key roles in projects, engineering, planning, operations, asset management, maintenance, and field resources development. I design and pioneer engineering solutions to propel the utility and energy industry forward. My passion within the industry has also driven me to develop educational materials for the new generation of utility and energy professionals. The knowledge I teach is not only based on my own experience within the power utility industry, but also on knowledge gaps identified by other professionals in the field. Learning from me will provide you with the comprehensive, fundamental knowledge you need to kickstart your professional career in the utility industry. If you are interested in what I have to teach, check out my courses at Udemy and connect with me on LinkedIn, X, and Facebook. Don't forget to comment, like, and subscribe this video. Bye for now.